So welcome to Sotantra education. In this lecture we are going to discuss some examples using the concepts of array. So the first program we want to write here to compute the sum of elements in an array. So we know that an array is a collection of similar types of elements. So here you can consider one array is there and the size of the array is assume 5 and the elements are 15, 17, 13, 10, then 23, and assume the name of the array is AR and its index is 0, because we know that the indexing starts from 0, then its index is 1, its index is 2, 3 and 4. Always the indexing starts from 0. Now what is AR of 0? So AR of 0 is 15, AR of 0 equal to 15, AR of 1 is equal to 17, AR of 2 equal to 13 here in this example, and AR of 3 equal to 10, then AR of 4 is equal to 23 here in this example. Now we want to find the sum of the elements. That means we want to compute 15 plus 17 plus 13 plus 10 plus 23, and we are going to find some value. Now how to assess the individual elements in an array? So we know that using the index we can assess the individual elements. So to find the sum we can write like this: AR of 0 plus AR of 1 plus AR of 2 plus AR of 3 plus AR of 4. Or we can say that 15 plus 17, this one 15 plus 17 plus 13 plus 10 plus 23 is equivalent to this one, AR of 0 plus AR of 1 plus AR of 2 plus AR of 3 plus AR of 4. So we want to compute AR of 0, AR of 1, AR of 2, AR of 3, AR of 4 like this. So instead of this we can write a loop. So in place of writing AR of 0 plus AR of 1 plus AR of 2 plus AR of 3 plus AR of 4, we can write a loop that is for I equal to 0, I less than 5, I plus plus, sum equal to sum plus AR of I. So instead of AR of 0, 1, 2, 3 like this, we can write AR of I, and the value of I is from 0 to 4. So this one. And formally we can write this thing using a loop for I equal to 0, I less than 5, I plus plus, sum equal to sum plus I. And initially we can take the value of sum as 0. So here we can initialize that sum equal to 0. So this is the program or code snippet to find the sum of the elements of an array. Now you can see the complete program for this. So please observe, this is the complete program. import java.util.scanner to take input from the user. We are importing the scanner class. Then class test, that is the name of the class. Then public static void main. So here we are defining the main method. So scanner IP equal to new scanner system.in. So IP is an object of scanner type that is used for taking input from the user. Then system.out.print enter size of the array. So we are asking the user to enter the size and assume the user enters 5. In previous example, in this example you can consider the size is 5 and the indexes are from 0 to 4 and the size is 5. So here we are asking the user to enter the size of the array. Now when the user enters any value, that value is stored in size, and here we are assuming that the user is going to enter one integer value because the size of an array is always integer. Now we are creating the array int square bracket ar, that is equal to new int size. So this one is square bracket, that is like this one. Okay. Then println enter the array elements. So here we are writing a loop to take inputs from the user. So these 2 lines, or you can consider these 3 lines, are for taking inputs. Taking inputs from the user. Now this part int sum equal to 0 for I equal to 0, I less than ar dot length. So here we know that every array knows its length. So here ar is the name of the array, and if you write ar dot length, so it is going to return the size of the array or the length of the array. So this part we have already discussed. Sum equal to 0, I equal to 0, I less than ar dot length I plus plus, sum equal to sum plus ar of I. So this part computes the sum. So here we can write this part is for computing the sum of elements. Now the last statement, this is for printing the sum of elements. So it prints sum of elements of the array is the value of sum. Here we count and that value is displayed here. So this is the complete program to find the sum of the elements of an array. So I hope this is clear to everyone. Now we will proceed to the next one. So write a program to compute the average of elements in an array. So how to find the average? So we know the formula for average is like this. Average equal to sum of the elements, sum division number of elements. So to compute the average, the formula is sum division number of elements. So using this formula we can find the average of elements in an array, and we have just now discussed how to find the sum of elements in an array, and this number of elements is equal to the size of the array or length of the array. So if ar is the name of the array, so we can write ar dot length to find the number of elements or the size. So simply you can see the complete program here. So here up to this we have already discussed in the previous part. So sum equal to sum plus ar of I, up to this we have already discussed. Now after computing the sum, we need to compute the average. So for that we are taking a variable average and we are converting the sum to double, because here the addition of integers results one integer value. So sum is one integer, and if we want to find the average in double or real numbers, then convert this sum to real number using typecasting. So for that we are writing here double before sum, then division AR dot length. Then after this statement we are writing system.out.println average of elements of the array is average. So it is going to display the value of average that is computed here. I hope this is clear. It is a simple one. Now we will proceed to the next program. So write a program to compute the average of elements in an array and find how many elements are above the average. So just now we have discussed how to compute the average and how to check how many elements are above the average. We need to compare each element with the average. So initially we have discussed this program while we are introducing the concepts of array. In the previous lecture you can see. Now to find how many elements are above the average, you can consider or compare each element with the average. So for this we can write AR of 0 is greater than average or not. So if AR of 0 greater than average, so we can increment the value of count. Similarly we check AR of 1 greater than average. So if it is greater than average, so we can increment the value of count, or we can write here if this one. Similarly we can write if AR of 2 greater than average, count plus plus. Similarly we can write if AR of 3 greater than average, then count plus plus. Similarly we can also write if AR of 4, so if AR of 4 greater than average, then count plus plus. So here we are considering 5 elements are there in the array, or the size of the array is 5. So for that we need to write this 5 times this identical code. If AR of 1 greater than average, count plus plus. If AR of 2 greater than average, count plus plus. If AR of 3 greater than average, count plus plus. If AR of 4 greater than average, count plus plus. Like this. So instead of writing this one, we can also write if AR of I greater than average, then count plus. And here the value of I is from 0 to 4. So this one, it is simple. So the value of I is 0 to 4, and we can write if AR of I greater than average, count plus plus. So instead of writing AR of 0, AR of 1, AR of 2, AR of 3, we can use a loop for this. So how to write this using a loop? So we can write this for int I equal to 0, I less than 5, or I less than AR dot length, you can write I plus plus. So if AR of I greater than average, then count plus plus. We can write simply. So this is the code using the loop to check whether one number is greater than average or not, whether the next number is greater than or not, or we can say to compare all the elements in the array and find how many of them are greater than the average and display the average. So at the end we can write system.out.println, or let it write in black, system.out.println count. So this is the code snippet. This is the code snippet to find how many numbers are above the average. Now you can see the complete program here. So up to this we have already discussed, that is the average of the array is this one. In the previous program we have already discussed this. So this part we have already discussed. Now consider this one. We are writing int count equal to 0. Then for I equal to 0, I less than ar dot length I plus plus. If ar of I greater than average, count plus plus. So this one we have just discussed. Now after the loop we are printing the value of count here. Value of count. So number of elements above the average is count, and here we are computing count using a loop. Now consider the next program, that is determine the maximum element in an array. Suppose consider the array of size 5. 1, 2, 3, 4, 5, and the elements are suppose 15, 13, 17, then 21, then suppose 18. Now assume the array name is AR, its index is 0, its index is 1, its index is 2, 3 and 4. So we need to determine the maximum element present in this array. So by observing the array, so you can find that 21 is the maximum element. So how we write the code to find the maximum element 21 here? So for this you can take, or you can write like this: maximum equal to AR of 0. That means we are saying that this one is the maximum, or we can say 15 is the maximum. Now comparing this one with this one, and if this is larger, then update the max value. So for this we can write, so if AR of 1 greater than maximum, then maximum equal to AR of 1. So we are comparing, this means this code snippet means we are comparing AR of 1 with AR of 0, or we are comparing AR of 1 with maximum, and if AR of 1 greater than maximum, update the value of maximum. Now in this example, so AR of 1 is 13 and it is not greater than maximum, so we are not updating maximum. So now maximum is this AR of 0, or we can say 15. Now apply the same technique again, that is if AR of 2 greater than maximum, then update the value of maximum. So what is the value of AR of 2 in this example? So in this example it is 17. So 17 greater than the present maximum is 15. So here the present maximum is 15. So max equal to AR of 2. So as this condition satisfy, update the value of maximum. So here the value of maximum becomes 17, and here it was 15, here also it was 15. Now again apply the same technique. So if AR of 3 greater than maximum, then maximum equal to AR of 3. Now consider what is the value of air of 3, it is 21, air of 3 is 21. So what is the value of maximum? 17. So air of 3 greater than maximum, that is 21 greater than maximum, yes it is true. Then update the value of maximum. So now we are getting the new value of maximum as 21. Again apply the same technique here and check for the next index value or next element. So air of 4 greater than maximum, then maximum equal to air of 4. Now here you can observe what is the value of air of 4. So air of 4 is 18. What is the value of maximum? It is 21. So 18 greater than 21? No, it is false. So the max value is 21. It is not going to be updated. Now after checking these numbers, because here the size is 5, the last element is at air of 4. So we have checked all the elements. So we can print system.out.println maximum. So it is going to print 21. So now you can consider this part. So you can consider this part here, this part and this part. So here we can consider, instead of writing if air of 1 greater than maximum, if air of 2 greater than maximum, if air of 3 greater than maximum, if air of 4 greater than maximum. So we can use a loop and we can write if air of I greater than maximum. So we can write this one like this: if air of I greater than maximum, then maximum, this is I, so maximum equal to air of I, and here the value of I is from 1 to 4 or 1 to air dot length minus 1. So here air dot length is 5. So we can write the loop like this: for int I equal to 1, I less than air dot length I plus plus, then if air of I greater than max, then max equal to air of I. So this is the code, and here before this consider that maximum equal to air of 0. So we are considering maximum equal to air of 0, and for rest of the elements we are comparing the elements with max. So here you can see the complete program. So here the import java.util.scanner, then class test, public static void main, scanner IP, system enter the size of the array, and after taking the size as input we are creating the array. Now this is for entering the array elements like we have already discussed, and here we are computing the maximum. So initially we are taking max equal to air of 0, then for I equal to 1, I less than air dot length I plus plus, if air of I greater than max, max equal to air of I, then print the maximum value here. So this is the complete program. Now check another one, that is to determine the minimum element in an array and also display the index of the minimum element. So consider the array is there, one array is there, and assume its size is 5. So it is 15, it is what are the next element, 15, 13, 17, 21, 18. 15, 13, 21, 17, then I think it is 18. 15, 13, 17, 21, 18. 15, 13, it is 17. 17, then 21, then 18. So assume this is the array, the previous array here you can consider. Now by observing the elements you can find that 13 is the minimum element, and here the index are also like this, 0, 1, 2, 3, 4. So following the same principle, we are going to consider that minimum equal to AR of 0, and after this we are going to compute, or we are going to compare each element with the minimum value, and if we find a new minimum then update the minimum. So now we are going to check if AR of 1 less than minimum, then minimum equal to AR of 1. Similarly we can write if AR of 2 less than minimum, then minimum equal to AR of 2, like we have discussed previously. Then if AR of 3 less than minimum, then minimum equal to AR of 3, like this we can write. Then again we write if AR of 4 less than minimum, we can write minimum equal to AR of 4. So here you can observe minimum is AR of 0, so that is equal to, initially it is 15. Now AR of 1, that is 13 less than minimum, yes it is true, then minimum equal to AR of 1, so the minimum value is updated to 13. Now AR of 2 less than minimum, AR of 2 17 less than 13, no, so the minimum is the same as the previous one. Then AR of 3 less than minimum, AR of 3 21 less than minimum, so then minimum equal to AR of 3. Here also no change, so the minimum value is 13. Now AR of 4 less than minimum, then minimum equal to AR of 4. So what is AR of 4? 18. So 18 less than minimum, no. So here also no update, it is 13. Now here we can find the minimum. Now in addition to minimum we want to find the index also. So here we can take another variable, that is index, and initially the index is 0. So when we update the minimum value, at that time update the index also. So here index equal to I, so here index equal to I, and here index equal to I, here also index equal to I. That means if we find a new minimum, the minimum is updated and also the index is updated. So initially index is 0. Now here if AR of 1 less than minimum, then the minimum is updated, so index is also updated. So the new index value is 1. So here no change in minimum, no change in index. Here also no change in index, here also no change in index, no change in minimum. So we are getting that the minimum value is 13 and the index in which 13 is present is 1. So instead of this repeatedly checking, these statements, we can use a loop like this. So initially we can write that minimum equal to AR of 0 and index equal to 0. Now for int I equal to 1, I less than AR dot length I plus plus, if AR of I less than minimum, then minimum equal to AR of I, and also update the index here, index equal to I. Okay, so this is the code to find the minimum element and the index of the minimum element. So you can see the complete code here. So similar to the previous code, here we are taking the size from the user and creating a new array, new integer array of size input by the user. So in the examples that we are discussing here in this lecture, we are considering only integer array. You can also consider the double array, float array, like that. So for simplicity, we are considering only integer array. Now enter array elements. So here it is also discussed previously how to take inputs from the user. Then this is the code that we have just discussed. So we are taking minimum equal to AR of 0, index equal to 0. So for int I equal to 1, I less than AR dot length I plus plus. If we find a new minimum, that means if AR of I less than minimum, then minimum is updated to AR of I and index also updated. Now after the loop here, just print the minimum element in the array is min and index of minimum element is index. So simple one. Okay, now consider another example, that is to find the index of a specific element in an array or search an element in an array. That means one element is given, find whether the element is present in the array or it is not present in the array, and if it is present, what is the index of that element. Suppose for example, consider this scenario like this. Suppose we have an array and assume it is of size 1, 2, 3, 4, 6 and the elements are 7, 5, then 13, then 9, suppose 23, then suppose 17. Now one element is given, assume it is 9. Now find whether the element is present in the array, and if it is present, find the index. So for that we need to compare this 9 with all the elements. So these are the indexes, like 0, 1, 2, 3, 4, 5 are the indexes. Assume the array name is AR. Assume array name is AR. Now we want to compare AR of 0 with the given element. Assume the given element we are storing in temp. So if AR of 0 equal to temp, then the index is 0, and if it is not equal to, then we will check AR of 1 equal to temp, and if this condition is true, then we can write index equal to 1. Then similarly you can check AR of 2 is equal to temp. So if this condition is true, that means AR of 2 is equal to temp, that means the element is present at index 2. If this is false, then we will move to the next one, air of 3 equal to temp, and if this is true, then the index is 3. So similarly we will check up to the last element, that is air of 5. Air of 5 equal to temp, and if it is true, the index is 5. So if none of these conditions are true, that means if this results false, this results false, this result false, this result false, this results false, then we can say the element is not present in the array. And for this purpose we can write this one. Instead of checking air of 0 equal to temp, air of 1 equal to temp, air of 2 equal to temp, air of 3 equal to temp, air of 4 equal to temp, air of 5 equal to temp. So instead of this we can write a loop for this, or we can write check whether air of I equal to temp, and if it is true, then index is I, and the value of I is from 0 to 5. So now you can see the complete program for this, or we can write this one using a for loop like this. So you can write a for loop for this. So for int I equal to 0, I less than ar dot length I plus plus, then if ar of I equal to temp, index equal to I. And before the for loop here, before the for loop we can take a boolean variable here. Boolean is found equal to false. That means initially we are assuming that the element is not present in the list, or we can say is found is false. Now if we found the element, so here we can write is found equal to true. So if the element is present, make the index is I and is found is true. Now here we can write if is found, that means if it is true, then print index, or here we can print index, and else we can find, or we can write print and not found. So the element is not present in the list, or not found we can write. So it is a simple one. So compare the element with air of 0, air of 1, air of 2 up to the last element, and if it is the element is present, just print the index or print the value of I here in the loop. So you can see the complete program. So here up to this we have already discussed, that is enter the array elements. So this one we have already discussed in the previous examples or previous program. Now this part, in this part we are asking the user to enter the element you want to search. That means the user is going to enter one element, and we are storing the element in the variable temp. Now we are taking one boolean variable not found is true, and we are comparing each element with the value of temp using a for loop. That means we are comparing AR of 0 equal to temp, AR of 1 equal to temp, AR of 2 equal to temp, like this. Now if this condition true, that means if any of the value or any element of the array matches with this temp, then we are just printing the index of the element is I, because here AR of I matches with temp, that means the index is I, and we are making not found equal to false. So initially we are taking not found is true and not found equal to false and break. That means here we are assuming that all the elements are distinct in the array, or the all unique elements are present in the array, non-duplicate elements are found. Now if not found, then the element is not present in the array. That means if this is true means this not found equal to false is not updated. That means this condition is never executed. This condition never returns true. This condition never returns true. That's why this not found is not updated to false, and when it is true, if not found is true, that means this one, and the element is not present in the list or in the array, it is going to display. The complete program is here. Okay. Now write a program to count the occurrence of a specific element in an array. So in the previous program we are searching whether the element is present in the array or not, and if the element is present, we are just finding the index. Now we want to count the occurrence of a specific element in the array, and here duplicate elements are present, and suppose one element is present how many times, we can find this one. So assume this is the array and the elements are 3, or let it be 13, 17, 11, 23, 31, then 24, like this. And assume the array name is AR and the indexes are like this: 0, always the index starts from 0, so 0, 1, 2, 3, 4, 5. Okay, so here the elements are not repeated, so assume some elements are repeated, so make it 13, make it 13, and this one make it 17, or make it again 13. Okay, so we want to find the occurrence of a specific element in an array. Now suppose we want to find how many times 13 is repeated in the list, or how many times 13 is present in the array or in the list. So for that we can take a temporary variable similar to the previous one and store 13 in temp. Now compare AR of 0 with, or is it equal to temp. So if AR of 0 equal to temp, then increment the value of count, where the value of count is initially 0. So count finds or determines how many times the element is present in the list. So initially count is 0. Now if AR of 0 equal to temp, count plus plus, so count becomes 1. Similarly check AR of 1 is equal to temp or not. So if it is equal to temp, then count plus plus, like this. That means first we are checking this temp value 13 with this AR of 0. So yes, it is matching, then count becomes 1. Now compare this one, 17 with 13, is it matching? No. Then 11 with this one, 13, is it matching? No. Now this 13 with 13. Is it matching? Yes. Now increment the value of count. So count becomes 2 here. So initially count is 0, and when this first one it matches, this count becomes 1. Now again when this match is found, the value of count becomes 2. Now again proceed to this one, whether it is matching with count, no. Then proceed to this one, is it matching with count? Yes. Then update this value to 3. So now we can say 13 is repeated 3 times here, because the value of count at the end is 3, and here this is 1, this is 1, this is 1, 3 times. Similarly for any other element we can find. Now in this way we can write, so AR of 1 equal to temp, then count plus plus. So in this way we will check up to AR of 5 equal to temp, then count plus plus. So we can use a loop for this, like we can write initially count is 0, then the loop is like this, for I equal to 0, I less than AR dot length, then I plus plus, or here you can write int I equal to 0. Now then we can write if AR of I equal to temp, then count plus plus, simple one. And in this way we can find how many times the temp is present in the list. So you can see the complete program here, this one. So class test, main method, scanner, enter the size of the array, then declare the array, enter array elements. So these things we have already discussed in the previous program. Now here we are taking the input, enter the element you want to search, and it is int temp equal to ip dot next int. So it was also there in the previous example. Now here our code starts, or actual logic starts for finding the number of occurrence of a particular element. So count equal to 0, then for int I equal to 0, I less than AR dot length I plus plus, if AR of I equal to temp, count plus plus. And at the end, that means after this loop, we are printing that count times the element is found in the array. So it is simple one. Okay. Now, so this is the main logic to count the occurrence of a specific element, and that specific element is stored in temp. Now move to the next one. So write a program to rotate the elements of an array one position towards left. So suppose the array is like this, AR, and assume it is 17, 13, 10, and the next element is suppose 5. Now we want to rotate the elements of an array one position towards left. That means this 5 comes here, the 10 comes here, 13 comes here, and 17 is going to here. Or we can say the new position of the element in the array are like this. So it is 13, 10, 5, then 17, and here the indexes are 0, 1, 2, 3, 0, 1, 2, 3, like this. So here you can write that AR of 0 equal to air of 1. That means if we write air of 0 equal to air of 1, the value of air of 1 is going to store at air of 0. That means 13 is coming to here. Now if we write air of 0 equal to air of 1, then 13 comes to here. So the value of 17 is going to lost, because 17 is overwritten here. 13 comes here. That means 17 is overwritten and we are losing the value of 17. So for this we can use a temporary variable that is going to store air of 0. So we can take a temporary variable and write temp equal to air of 0. Now we are storing the value of air of 0, that is 17, at the variable temp. So here we are storing 17. Now next statement, air of 0 equal to air of 1, that means 13 is coming to here. Now similarly we can make 10 to here. So if we write in this way, air of 1 equal to air of 2, that means the element that is present at air of 2 is coming to air of 1. That means 10 is coming to here. So no issues, we can move in this way. Then similarly we can write air of 2 equal to air of 3. Now if we write air of 2 equal to air of 3, the element present at air of 3 is coming to air of 2. That means 5 is coming to 10. Consider the array elements after execution of each statement. So here initially 17, 13, 10, 5. So after execution of this statement, temp equal to air of 0. So the array elements are 17, 13, 10, 5, and in variable temp 17 is there, or we can say in one variable temp 17 is there. Now after execution of this one, air of 0 equal to air of 1, that means this one is coming here. So we can write like this. So 13 comes here. So after execution of this statement, air of 0 equal to air of 1, the array looks like this: 13, 13, 10, 5. Now move to this statement, air of 1 equal to air of 2. That means the value of air of 2 is coming to air of 1. That means 10 is coming to here. So after executing this statement, so the value of 10 becomes here, and the array looks like this. So after executing air of 1 equal to air of 2, the array looks like this. So 13, 10, 10, 5. Now if we execute this one, air of 2 equal to air of 3, that means the value of air of 3 is coming to air of 2. So here the array looks like this: 5. So 13, 10, 5, 5. Now this 5 is repeated and we want to put 17 here. So for that we can write air of 3 equal to temp. Now if we write air of 3 equal to temp, that means the value of temp is coming to air of 3. That means this 5 is overwritten by 17. So after executing these statements, we are going to get the desired result. That means we are going to get 13, 10, 5, 7, 17. And in this way, one position is shifted towards left. So we can use a loop to write these things. So we can forget this one. So we can use a loop for these 3 statements instead of repeatedly writing. So how to write these things in a loop, you can see it here. So we can first write for int I equal to 0, I less than ar dot length minus 1, then I plus plus, right, ar of I equal to ar of I plus 1. So for shifting one position towards left, so for I equal to 0, I less than ar dot length minus 1. So in this example, what is ar dot length? It is 4, and I less than ar dot length minus 1, that is I less than 4 minus 1, that is 3, and I less than 3 means for I equal to 2 we write this one. So from I equal to 0 to I equal to 2, these things we are writing, you can observe. ar of I equal to ar of I plus 1. So ar of 2 equal to 3, ar of 1 equal to 2, ar of 0 equal to 1, like this. Now at the end, that is ar of 3 is temp. So here we can write a temp variable to present to store ar of 0. Then after the loop we can write ar dot, we can write ar of ar dot length minus 1 equal to temp. So this is the logic to shift one element towards left. So you can see the complete program. So here class test, main method, then size of the array, the user is going to enter, and we are creating the array of size that is entered by the user. Now enter the array elements, and user is going to enter the array elements. So this part is similar to or exactly same as the previous example. Now here we are shifting one element towards left. So we are using a temporary variable temp and storing ar of 0. Then for I equal to 0, I less than ar dot length minus 1, I plus plus, ar of I equal to ar of I plus 1. Then after the loop we are writing this one, ar of ar dot length minus 1 equal to temp. Now we are printing the array elements after rotation, that is we are taking one variable I equal to 0, I less than ar dot length I plus plus, just simply print ar of I. So this part is for displaying the array elements, and this part is for shifting one position. So you can observe this part is for shifting elements, and this part is for displaying the array, and here it is for input. So this is the complete program, you can see. So similarly you can shift any position towards left, any position towards right. Suppose if you want to shift 2 position towards left, then we need to take 2 temporary variables to store the value of ar of 0 and ar of 1. After that shift each element towards 2 position to the left, that means 10 is coming to here and 5 is coming to here. Similarly, if we want to shift 3 position towards left, then we need to store first 3 elements in another variable. So in this way you can take a array of size 3, or you can consider 3 different variables to store the elements. Similarly, you can shift towards right also, shift towards left also, no issues. So you can practice these programs. Now we want to find, or we want to reverse the order of elements of an array. So suppose one array is there, and assume the elements are 12, 15, 17, 13, 23, then 19, and the index is 0, 1, 2, 3, 4, 5. So here assume name of the array is AR, and here the size of the array is 6, and we have 6 different elements in the array. Now we want to reverse the order of elements in the array. That means we want to swap this 12 and 19, or we can say if we reverse the order of elements in the array looks like this one. So 19 comes here, then 23, then 13, then 17, then 15, then 12. So the index is 0, 1, 2, 3, 4, 5, and it is the same array AR. So initially the elements in the array are in this order, that is 12, 15, 17, 13, 23, 19. Then after reversing the order of elements, the elements are in this order. That means first 19, then 23, then 13, then 17, then 15, then 12. So 19 comes here, 23 comes here, and 12 comes here, 15 comes here. Or we can say we are swapping the first element with the last element, if you observe properly. So here we are swapping these two elements, then again we are swapping these two elements, again we are swapping these two elements. So if we swap the first element with the last element, second first with second last, third first with third last, then we are going to get the reverse of the array. So how to do this, or how to perform this swapping? So here you can observe we are swapping the element that is at index 0 with the element that is at index 5. Similarly, the element that is at index 1 with the index 4. Then we are also swapping the element that is index 2 with the element that is at index 3. So after 3 swaps in this example, we are going to get the reverse of the array. Now we can write this as I, and we can write this as j, and we can use a loop for this swapping, for the number of swapping. Now when the loop is going to terminate, so the loop is going to terminate, or here you can observe the value of I is increasing and the value of j is decreasing. So it is 5, 4, 3, it is decreasing. Here I 0, 1, 2, it is increasing. Now after this, after 2, the value of I becomes 3, and after 3, the value of j becomes 2. When you can observe, when the value of I becomes 3 and the value of j becomes 2, the swapping is not required. Or in terms of I and j, if we want to write, So when I greater than equal to j, stop the loop or stop the swapping, because swapping is not required. And when do the swap? When the value of I less than j, then swap the elements. So I less than j is the loop continuation condition. So we can write this in this way or like this: for int I equal to 0, and we know that the value of I is 0 here, value of I is 0, and the value of j is 5. So what is 5? So the last index. So how to find the last index? That is length minus 1. So we can write like this: j equal to ar dot length minus 1. Then the condition is loop continuation condition: I less than j, then I plus plus j minus minus. So increment the value of I and decrement the value of j. Then we can write swap ar of I with ar of j. Simple. Then how to swap this one? So how to swap ar of I with ar of j? So if we write like this: ar of I equal to temp, then ar of I equal to ar of j, then ar of j equal to temp. So this is the code to swap, or we can say this is the code snippet to reverse the elements of an array. Now you can see the complete program here. So here this part is already discussed. Enter the size of the array and create the array of the given size. Then enter the element, that means take the input from the user and store them at ar of I, that means ar of 0, ar of 1, ar of 2, like this. Now this is the logic to reverse the order. So here this part is for reverse the order of element. So here we are using a loop: I equal to 0, then j equal to ar dot length minus 1, the condition is I less than j, then increment value of I, decrement the value of j, that is the updation condition. And here we are swapping: int temp equal to ar of I equal to ar of j equal to temp. So these statements we have just discussed. Now this part system.out.println the array elements after reverse operation are, we are using another loop and printing ar of 0, ar of 1, ar of 2, like this. So this part is for printing the elements or displaying the elements, printing the elements. So this is the complete program you can observe, or you can find the complete program in the question answer section of the website.